While Yellowstone's volcano is dormant, another major danger lurks. Yellowstone National Park is famous for its bubbling hot springs and steaming geysers. This hydrothermal wonderland is powered by a cauldron of partially molten rock deep underground. It holds enough boiling magma to build several Mount Everests. Yellowstone's last eruption was 70,000 years ago. If it were to erupt again, vast areas could be buried under lava. Most scientists think this is unlikely, at least for the next few thousand years. But there's another serious danger lurking that's more sudden and dangerous than lava. To understand its destructive power, it helps to know what happened a decade ago on Japan's Mount Everest. On September 27, 2014, the weather was sunny with a light breeze. At 11:52 a.m., more than 100 climbers stood on the summit, enjoying snacks and taking pictures. Then trouble struck, and it came without warning. The windows of a nearby hut suddenly shook, shaken by a powerful shock wave too low for human ears to hear. Then a huge gray cloud billowed from the southwest slope of the mountain. It swept over the top of the mountain, blinding people in a swirl of dust. They could not see as millions of tons of rock and dust, thrown from the mountain, rained down on them. 63 people died. Most were killed by falling debris. However, this volcanic eruption was not caused by lava or fire. It was powered by water. A pool of underground water suddenly heated up, probably by volcanic gas or magma rising from below. The water boiled into steam almost instantly. As this happened, the water expanded hundreds of times its original volume. This shattered the mountainside, sending rocks flying into the air. This type of steam eruption is called a phreatic eruption. It is triggered by a sudden pulse of heat inside an active volcano. But similar steam eruptions, called hydrothermal eruptions, can also erupt far from an active volcano. Yellowstone is pockmarked with craters left by these eruptions. There have probably been thousands of them over the past 14,000 years. That includes one massive eruption on July 23. It sent rocks flying and tourists running. In the past century, there have been only small ones, says Paul Bedrosian. He's a geophysicist with the U.S. Geological Survey, USGS, in Lakewood, Colorado. But we know that Yellowstone is capable of producing big earthquakes, he says, ones that are much bigger than the Ontake quake. To learn what triggers them, researchers have been exploring the depths of Yellowstone Lake, on the park's eastern side. Hundreds of hot vents dot the lake's floor. The lake bed is also home to some of the world's largest hydrothermal vents. And from the lake's floor rise hard, brittle domes that could one day explode. Hydrothermal eruptions are very, very dangerous, says Lisa Morgan. She's a volcanologist with the USGS in Denver, Colorado. For 25 years, she's been studying Yellowstone's largest eruptions. Scientists have been studying Yellowstone's hot springs and geysers since the late 1800s. But it wasn't until 1966 that they realized that the place had once been the site of a massive steam explosion. That summer, Patrick Muffler made his first visit to Pocket Basin. It was near Yellowstone's western edge. He was a young scientist with the USGS. He was traveling with his boss, Donald White, a USGS scientist who studied hot springs and geysers. Pocket Basin was a large, bowl-shaped meadow. A rocky ridge surrounded it on three sides. Hydrothermal pools and springs were scattered throughout the meadow. They scented the air with the sour smell of hydrochloric acid. The acid was constantly seeping out of the hot water bubbling up from below. As the two scientists explored the area, White noticed something he had seen before. In 1951, he had visited Lake City, California, to see something strange. Five nights earlier, a group of once silent hot springs in the marshy meadow had erupted. The eruption threw 300,000 tons of mud and rock into nearby fields. The rocks are made of gravel and sand. They have been cemented together with minerals, whitish zeolites and opals. White knew that these materials formed when hot water full of dissolved minerals neared the surface. As the rising water cooled, the dissolved minerals crystallized into solids, forming these rocks.